First of all, let's realize the distance formula is simply the result of the Pythagorean theorem. So let's start with an example. This video will be about applying the distance and midpoint formula. Objective of it, at the end of this lesson, students should be able to use the coordinate system to compute length and the midpoint of a line segment. Students should be able to use the distance and the midpoint formula. So let's get started. Everybody should have seen this probably in geometry, so this will be sort of a Okay, so let's get started. Let's say we got 2 points and we want to know the distance between the 2 points. Let's say one point is at 4 and 1. A second point is at -3 and 5. Okay, so there's our 2 points, and we want to know the length of this segment. Let's just draw a straight line, and let's label these points just for, and this we said was again 4 and -1, and this point is -3 and 5. So those are 2 points, and we want to know the length of that segment. Let's go forward by label the points as well. So if this is the first point, let's label this point. That's the x value, x1 and y1, and this is our second point. So let's label this x2 and y2. Okay, so if we want to know the distance between these 2 points, notice if we create a right triangle, then we can use the Pythagorean theorem to solve it. So let's create our right triangle. Let's draw here and right over there. Here will be our right triangle, and this point would be -3 and -1. -1 at this point. And let's, for a quick review, the Pythagorean theorem tells us if we take the length of the legs and label one leg A and square it plus B squared equal C squared. Again, that's just the length of the legs, and the length of the legs squared. Okay, so let's label, on our Pythagorean theorem, let's label our sides. Let's label this side A, this side B, and then the hypotenuse is always C. Notice the length of A is just our x values. So A would simply be equal to -3 minus 4, which would give us -7. B is the length of our y values, this line here, and that will simply be -1 minus 5. -1 minus 5 would simply be -6. So our formula takes -7 squared plus -6 squared should give us C squared. -7 squared is 49. -6 squared is 36. And that should give us C squared. 49 plus 36 gives us 85. And that equals C squared. And remember, to get C, we have to take the square root of that. So C is equal to the square root of 85. Okay, now let's look at what we did. Look at what we did to compute the distance. So again, C would be equal to the square root of 85. Let's look at what we did to compute the distance. We simply took our x values, so our 2 points, x2 minus x1, and squared it. Then we added that b to our y values. We added that to our y values, which was simply y2 minus y1, and then we squared it. And then to get our final answer, we took the square root of all of that. We took our a's, took this, and that in fact gave us our distance. And there is our distance form. Distance form equals x squared, x2 minus x1 squared plus y2 minus y1 squared. Okay, let's look at an example. Let's say we had 2 points. Say we had a point at, say we had a point at 0. We had 2 points at 0, 0. Say we had a point at 0, 0, and another point at 8 and 15, which will obviously be off. Let's say it right here. Let's call this 8 and 15 and 0, 0. And we're simply looking for the length of this segment. And again, our distance formula basically said we're going to take the square root x2 minus x1 squared plus y2 minus y1 squared. Okay, and if we do the math, distance formula, and let's label our points. Let's call this x1, y1, x2, y2. So again, our distance formula will be simply 8 minus 0 squared plus 15 minus 0 squared. Distance formula would obviously be 8 minus 0 is 8. Square would be 64. And let's pull out a calculator to get 15 squared. Here, let's go down. And 15 times 15. So 225. So this would be plus 225. So our distance form would basically be equal to, let's go back to our calculator, plus 64. So our distance form will be equal to the square root of, our distance form will basically be equal to the square root of 289. And just quick check of math, and the square root of 289 would be, I think that's 17, so let's just simply check it. 17 times 17 equals 289, so our distance formula is 17. That will be the length of that segment. Okay, and let's look at one more example. Let's say we got a point at 0 and 6. And again, this is 0 and 6. And say we got another point at 8. And 0 and 6 and 5 and negative 4. Let's move this over here. And 0 and 6 and 5 and negative 4. And so that's right here. And we want to know the length of this segment. And again, it says 5 and negative 4. So let's put it into our formula. Let's do it right down here. So we know again the distance formula is going to be simply x2 minus x1 squared plus y2 minus y1 squared. And we simply can put in our numbers in here. So again, let's label them. Let's call this our second point. So x2, y2, our first point, x1, y1. So we simply going to say 5 minus 0 squared plus negative 4 minus 6 squared. That will give us 5 squared plus negative 10 squared, which gives us 25 plus 100, so 125. So the distance is equal to the square root of 125. Now, just as a quick reminder to simplify square roots, 125 doesn't have a perfect square, so we will look for any perfect squares in it and factor them out. So 125, we know 5 is a factor of it, is 25 times 5. Or the square root of 25 times the square root of 5. And so in essence, the distance will be 5 square root 5.